This problem is an example of observing patterns to notice key mathematical ideas. So really in this problem, I'm trying to lead you to the formula of what the volume of a cone is, and we're gonna do it in a way where we look at pyramids and how as we increase the number of sides of the base, it looks more and more like a cone. So it's actually a similar case of how you may find the formula for the area of a circle. If you look at a square and then a pentagon and hexagon, and you slowly increase the sides over and over and over, eventually you're actually going to derive the area of a circle. But here, we start with a very simple shape, simple meaning less size in the base of this pyramid. So I've listed out a square pyramid here. And what I'm asking you to do is just use your knowledge of the volume of pyramids to find the volume of each of these figures given the variables and the numbers that I give you. So I'm going to go through the first two to give you an idea of what I'm looking for in this problem, and then you're going to see pretty quickly what the rest of it should be. So the first question refers to the first figure right here, and it says if the area of square A, that'd be this square right here, is X, what is the volume of a pyramid with square A as a base and the height H? So the key thing to remember here is the area of any pyramid is, the volume of any pyramid is 1/3 the volume of a prism with the same base. So what would the volume be of a rectangular prism with this as a base, so really a cube? Well, it's going to be the area of the base times the height. That's what it was for all prisms and cylinders too. So for the area of the base, well, that's simply X, because we called the area of this square A to be X. That's some number. And the height is H. So it would just be XH. The volume of a prism with this square as a base is XH. So all we need to do to get the volume of this pyramid is we need to simply times that by 1/3. So I'll write that right here. We would get something like 1/3 XH. Now let's look at the next one. Here we have a little more complicated base, not complicated, more sides in that base. We have a hexagonal prism. So it's a prism where the base is a hexagon, but still that same shape of extending upwards towards a single vertex. So what is the volume of this hexagonal prism if the area of the hexagon is X? That's what I say right here. And the height is H. Well, it's going to be the same thing. It's going to be that 1/3 XH, because again, it's going to be 1/3 times the volume of the prism with the same base. And in this case, this hexagonal prism would be XH because the area of the base is X and the height is H. So continue on downwards and then notice the pattern of what's happening as we get closer and closer to what looks to be a cone.